So I put less than a full workday into this system model, and I went ahead and had imported the content from the NASA functional hazard analysis. I'd like to show you some of the outcomes of that. So as I'd shown in the original import video, I was able to import functional blocks along with their operations. I was able to import the operational consequences. So those were the name, documentation, hazard classification, which I made an enumerated list, so I can it's error check that it has to be one of the specified ones, as well as the remarks. I imported the functions that were provided in the report. I also imported or created a bunch of signals that reflected my assessment of what had to flow in between functions based on what they were, like generate AGT commands. So there's obviously some sort of AGT command message, that sort of thing. And so I went ahead and I just want to show you some of the things that I did with all of these. So for starters, with the operations, I created a trace table that let me trace the functions or operations to the operational consequences, which I modeled as use cases. So basically all of the information in the functional hazard analysis I used to put these traces in, and in some cases there's more than one, but I went ahead and I created this matrix and created the relationships between the operations and the operational consequences. So that's rigorous and connected. I also created, if we look at this table, it shows the function, it shows the parameters. So these are the messages that are sent in or out, the inputs or outputs for the function. And I created a bunch of derived properties here. So these basically use Magic Draw's meta-chain navigations to follow those traces and return the operational consequences that have these particular severities. So it was pretty straightforward to do that. I'll show you what they look like. In this case, this is a derived property, and it's basically returning any use case that has a hazard classification of catastrophic. And inside this, we had a scope here that this was basically using the trace relationship to go from the function to the use case and then filter it. So all these are set up that way. So again, this gives us nice rigorous information about, for a given function, what the different categories of operational consequence there are that are related to it. And in addition, if we go into the specification window for any of these, there's a traceability section that then shows all of those appear here. And so it's very easy when working in the model to open up any element and see the operational consequences. So that is for the functions themselves. I also did a roll-up for the blocks, because often you want to know about the owning element that contains a function. We don't normally talk about specific functions. You'll talk about a system, that sort of thing. So I create a set of derived properties that let me do the same thing at the block level, so it rolls up anything that's owned by it or realized by it. I'll show why that's important, because in our case of the way we architect this, the functional block is specialized by a logical block that's then realized by a physical block. And so if we look at the specification window for this, we can see that this has a variety of outcomes or operational consequences traced to the functions that it owns. Those same ones, because of this relationship and the way I structure the derived properties, they also show up automatically here inside the traceability at the logical level, and they also show up here as a outcome at the physical level as well. And so again, just by creating two relationships, we can expose all of that information of operational consequences all the way down to the physical level with just a handful of relationships. That's why modeling is so efficient. We don't have to make all these individual links and lose track of things. We can inherit and trace these relationships very easily and effectively. And so the logical blocks table does the same thing. In this case, it shows the material that's, or the operational consequences that are being inherited by the logical block. I also worked on a signals table and added a safety classification to that, and that was informed by the parameters table here. So that follows the parameter to the function that owns it as an input or output. We go ahead and get the type, which is the signal. Actually, I should probably just show the direction while I'm at it as well. So this is a parameter, and this shows us that this is, an AGT command in, and this has it coming out. And we can see the severities here. So if we do a quick filter on catastrophic, we can see that these severities are the roll-up of the traces coming out of this function, and so these commands are related to catastrophic outcomes for functions, so they're probably safety critical. Then I did the same thing for hazardous, and again made sure those are safety critical. Then I went to major and was able to make sure that all the ones that weren't also catastrophic and hazardous, I categorized as safety significant, etc., etc. So here's a case where the model's talking to us. The messages that flow in and out of a given function can be assessed in terms of the severity of the operational consequence of that function malfunctioning, and we can assign the classification for the signal. So again, very quick, very fast to be able to ensure consistency with this. And then finally, I also went ahead and made a hazards table here that basically used the relationships we had to color code these using an icon to represent the severity of the operational consequence they're tied to. So you're able to very quickly generate this attractive chart that quickly lets you see what's going on. You can drill in, you can hide things. There's full traceability. We can very quickly see what's going on. Works extremely well, and especially if you're, again, trying to have the data talk to you, it's very nice to be able to do the work to ensure that all of the information's correct, is accurate. You can look for empty rows, empty columns, look for orphans and widows. It's really a great way to view the analysis. So again, I'm hoping that these videos are showing that data we enter and create, and here's a table of all the traces. So I took all of their statements and went ahead and put them in, and then connected the function to the operational consequence. So again, this is just a small set of data, but it can be represented in all these tables, traces, derived columns. The sky's the limit when it comes to putting all this together to ensure clarity. And of course, all this could be exported very easily to a report. I auto-generated one out of here. It was about 17 pages or so and included all these diagrams and content, so it worked out very well. Final thing I do want to show is that the reason we use the operations is that these parameters are the input and output pins when you actually drag them onto an activity diagram, and so that ensures that they're typed correctly. That was a bad choice, my apologies. Here's one that has inputs or outputs. So again, the pins appear and let us so this one has corrective action command coming out, and so again, that by wiring this up, we can see that it should throw an error here in a second because those are typed differently. So this is the sort of thing that gives us the ability to have some rigor and make sure that, again, all of our messages and such are consistent. So I'm very much a fan of using object flows and inputs and outputs on activity diagrams. And then, of course, the final diagram I'm going to show you is a example subsystem I put together. And again, it's also throwing an error because I've categorized this message of transponder data as being safety related, and this is a non-safety related network, the way the interface is set up. So again, when you set things up competently, the system does a lot of error checking for you to help you catch mistakes. So long and short of it is, again, functional hazard analysis, read in, imported, connected up in a matter of hours with a lot of exposed information. Redundancies were caught. I mean, a lot of these operational consequences, there's several that are very similar and worded slightly differently. Again, we should be consistent, pick the one we want to have, standardize on that, help singularize it. Again, just get down to a nice consistent set of information. So hope this helps you understand the things that are possible by competently executing a system model and how much the derived products, these tables and matrices, can do, along with the derived properties to help inform your systems engineering. Thanks for watching and have a great day.